let us see this question. The question says a farmer has to go 500 meter due north, 400 meter due east and 200 meter due south to reach his field. If it takes 20 minutes to reach the field, what distance he has to walk in order to reach the field? See, let me draw the figure first. The farmer is going due north 500 meter, and then he goes 400 meter east, and then he goes 200 meter south. So this is 400. Say he start from A, go to B, and then from B to C, and suppose B to C is 400 meter and C to D is say 200 meter, and during this whole process it takes 20 minutes. What distance he has to walk to reach the field? See, the distance he has to walk is 400 plus 4, sorry, this is 500. The distance he has to walk is this 500 plus 400 plus 200, that is 900 plus 200, 1100 meter. Then the question is, what is the displacement from his house to the field? Suppose here is the house and here is the field. Here is the field. This is house and this is field. So we want displacement. Displacement means you have to give me the straight line distance between, you have to give me straight line distance between initial position and final position. That's the displacement. We have to find this value, right? So in order to find this AD, what I can do is, let me draw like this, parallel to this BC. So this will also be 400, and this is 200, this is 500, so this will be 300 meter, this distance, right? Let's call it G. So your DGA is right angle triangle. So one can say the displacement AD, the square of displacement AD equals to AG square plus DG square, that is 300 square plus 400 square. So AD comes to be 500 meter. It will be 500 meter. Alright, that will be displacement. What is the average speed? See, speed is what? Speed is the magnitude of velocity, and average speed is the integral of v dt upon integral dt from say 0 to t. T is 25 centimeter, 25 second. And what is this? This is distance. So distance traveled is, this is the total distance traveled upon, in denominator is total time. So that is going to be, total distance traveled is 1100 upon 20 minutes. So 20 minutes has to be expressed in terms of say seconds, 60. So that would be 11 by 12 meter per second. And what is the average velocity? Average velocity is going to be this. So this will come out to be displacement. This is displacement. You know this, that V is dr by dt. So that is integral dr, the dr is going to be v dt. So delta r is, delta r means the final minus initial vector, initial position vector is v dt. So this is your delta r vector basically. The vector from A to D is delta r vector. So this is going to be equal to 500. If I am interested in magnitude, if I am interested in magnitude, the direction of delta will be this. So direction of average velocity will also be this. Direction of delta is this. So direction of average velocity is also this. But right now I am not interested in the direction. I am just giving you the magnitude. That is 500 displacement upon time, which is 20 into 60 again. So that would be 5 upon 12 meter per second in the direction of AD, in direction of this AD vector, in direction of displacement vector, right? So this is going to be the average velocity. This is going to be the average velocity. Okay, now let's move to next question. See, the question reads: a motorboat going downstream overcome a raft at a point A. Tau equals to 60 minutes later, it turned back and after some time passed the raft at a distance of L equals to 6 km from the point A. Okay, so suppose A is the point and the river is flowing in this direction. We suppose the river velocity is VR. So the boat is this is the boat. So it is meeting the raft over here. It goes like this. It goes on like this for the time period of tau. So tau is 1 hour. Tau is 1 hour. All right. So during tau time, the velocities of the boat would be what? Velocity of boat would be suppose velocity of boat is VB. So boat will certainly inherit the velocity of river also. So net velocity of boat would be VB plus VR in downstream. This is in direction of stream. In the direction of stream, the velocity, net velocity of boat is going to be its own velocity VB plus velocity of the stream which is going to inherit. See, every boat inherits the velocity of the stream, right? So if it is moving downstream direction, then velocity of stream will get added to its velocity and will give you net velocity. If the boat is moving upstream, then velocity of river gets subtracted from the velocity of the boat in order to give you net velocity. So it is moving downstream for tau time. So its velocity in this direction is going to be VB plus VR. And suppose it reaches point B. Getting a point? Now from here it returns back, and here there was a raft. Here there was a raft. So when he returns back, he meets the raft at some position like this, and this distance is going to be that's given to you, that is equal to L equal to 6 km. So while it returns, it meets the raft at this point, which is L distance from this A, distance L from the A. You got your problem? This is the river and this is the boat and this is point A. Here was the raft. Boat moves in this direction and goes to point B, then returns back, and the raft will, of course, raft does not have any engine, so it doesn't have its own velocity. Raft will move with the velocity of the stream only. So raft in that time, raft will also move in this direction with the velocity of the stream. So he meets the raft over here. The boat meets the raft over here. So while the boat moves in this direction, its velocity will be VB plus VR. While the boat moves in opposite direction, its velocity is going to be VB minus VR. And the velocity of raft will be VR. Raft will inherit the velocity of the river and will move with the velocity of river. So, and this distance is given to you. This is the L. So suppose while it returns, it moves for the time T. See, from B to this point called C, B to C. Suppose the boat moves to a distance, to this distance. When it meets the raft, suppose the time taken by boat from point B. B is the point from where it returns. from point B till it meets the raft. It meets the at point C is T. So during that time the distance traveled by boat would be VB minus VR into T, and during that time the distance moved by raft is L. So VR into, so during this time while the boat returns, this distance is going to be VB minus VR into T, and distance AB is going to be VB plus VR into T. So this distance minus this distance will be L, that is VB plus VR into T, not T, this time is given to you, this is tau minus VB minus VR into T is L, and during this time interval tau plus T, the raft moves a distance of L. So the raft is moving at VR velocity, and total distance traveled during this time is L by the raft. This is the displacement of the boat in tau plus T time. The displacement of the boat is also L, but that displacement is expressed as distance traveled during downstream journey minus distance traveled in upstream journey, and that difference is L, right? Okay, so this gives you what? This gives you, if I open it, this will be VB, yeah, plus VR, sorry, okay, this is VB tau minus T plus VR tau plus T is L, and this is also L from here. So this L will cancel out, that means tau minus T is 0, that is T is tau, this time interval is tau, and when T is tau, from here when T is tau, this is VR into, or VR is L upon 2 tau. Velocity of river is, flow velocity is VR L upon 2 tau. You understand this point? Okay, let's go to next question. Okay, the question is, a point traversed half the distance with velocity V naught. Suppose L is the total distance, suppose L is the total distance from A to B. So half of the distance, the point travels with velocity V naught, alright, V naught is the distance traveled, and this distance is say L by 2, and the total distance is suppose is L. So half of the distance is traveled by with velocity V naught, uniform velocity, and then remaining half is covered with velocity V1 for say time interval t, and V2 for another half of time. Suppose this is C, then time taken by the particle to move from C to B is suppose 2t. So for t time it travels with V1, and for next t time it travels with V2. That is we can form the equation from here. V1t plus V2t is L by 2, right? L by 2. And what's the time taken to move AC distance? Time taken to move AC distance is going to be L by 2, say call it T3, T dash, say L by 2 by V naught. We have to find mean velocity V, that is integral V dt by integral t. But this V is going to be different for different time interval. From 0 to t dash, time interval from A, journey from A to B, suppose total time is 0 to t naught, but this t naught consists of t dash plus t, and velocity during t dash is v naught, velocity during next t is v1, and velocity during next t is v2. So we will break this integral into 0 to t dash v dt, which is L by 2, and then from 0 to t, which is v is v1, and then again from, sorry, it should not be like this, from t dash, yeah, you can say 0 to t also, because this is from this time interval is t, and then again from 0 to t with some velocity like this, and the total time is going to be t dash plus t plus t. So this is L by 2, and this is going to be v1t, this is v2t, t dash plus t plus t. So what is t? T is L by 2 v1 plus v2. So this is L by 2 v1 plus v2, or this will also be L by t, of course, L by 2, and t dash would be L by 2 v naught, and t will be, this is 2t, so t plus t is 2t, so twice, this is L by 2, right? So this will cancel out. So what do we get? This is L so that will give you what? 2v naught, as is that's the answer. Getting a point, right? So let's move to next question. Car starts moving rectilinearly, first with acceleration w, 5 meter per second square. The initial velocity is 0, and then uniformly, and then finally deaccelerating at the same rate w, and comes to stop. The total time of motion is tau. The average velocity during that time should be is equal to v. How long the car moves? So first we have to convert it to meter per second, because everything is in second and meter per second square. So this is 72 into 1000 upon 3600. Hour has to be converted into second, and kilometer has to be converted into meter. So it is 5 meter per second. So you have to put the value 5 meter per second. I think I am correct. No, this is 20, sorry, 36, 2 should be upward. So it is 20 meter per second. Alright, we convert it to desired unit. So let me show you this whole thing in a graph, what the question says. See, it accelerates. Suppose this is a velocity versus time graph, right? So it accelerates with w, and then moves uniform velocity, and then it deaccelerates like this, right? Okay, so suppose it moves with uniform velocity for the time interval t naught, and of course see, since it is accelerating to this velocity, and then from this velocity it is deaccelerating at the same retardation, this w over here, and this deacceleration is also same, so this time will also be same. So this is say t1, so this will also be t1. Now t plus 2t1 is tau. Get your point? We have to find t over here, and average velocity would be what? Average velocity is going to be the total displacement by total time. So what could be total displacement? Total displacement would be area under this graph. It's a rectilinear motion. So just find area under this graph. So that would be area of this triangle plus area of this triangle plus area of this rectangle, or this you can say area of the trapezium. It's a trapezium, right? So during that time, during t1 time, the velocity it will reach is going to be how much? wt1. You know, v is u plus at, u is 0, a is w, and t is t1, so it will be wt1. So you can say area of trapezium is how much? Area of trapezium is 1 by 2 into height wt1 into yes, sum of parallel sides. So it is 2t1 plus t is one parallel side, plus this side is also t, and this is total distance traveled. So total displacement, what should I say, x. So that would be what? wt1 is t1 plus t, and your average velocity that is given to you, so that is x upon total time taken. Total time taken is tau. You are given this tau, so this is wt1 upon tau equals to this. Get your point? That is given to you. So from here you get an equation, t1 plus t is upon w, and the second equation was t plus t1 is tau. So from here, if I see this, what I need to find is t. I want to find t basically. So from here we get t1 as what? Tau minus t by 2. So this will give us what? Tau minus t by 2. Okay, and this will give me what? t1 plus t would be, we can say or let me write like this here, so tau minus t by 2 plus t. So can you do it after this, or should I do it for you? This is going to be tau minus t, and this is going to be tau plus t upon 4. So this is tau square t square and this is 4 upon W. This is W, not omega, W. So what do you get? T square is tau square and then T is what? This. Alright, that's going to be your answer, right? Okay, or you can put it like this also, 1 minus omega tau. That's the time taken. That's the time during which the body tells you the uniform velocity. Okay, getting a point? Let's move to next question. See this question. In a car race, car A takes time t less than car B at the finish and passes the finishing point with velocity v more than that of B. Assuming that both the cars starts from rest and tail with constant acceleration a1 and a2, show that v is this. Okay. So suppose you have A and B starting from the same point and they reach the finishing line. This is finishing line. So car A takes t time less, right? So suppose car B takes t naught time and the velocity it reaches v naught. So car B, okay, car B. Let's suppose car B has the velocity v naught and time is take is t naught. So you can say and car B is moving with a2, right? So I can say 0 plus a2 t naught is v naught, and car A takes t time less, so it takes t naught minus t time, and the velocity it reaches is v naught plus v, and the acceleration was a1. So I can say 0 plus a1 t naught minus t is v naught plus v. During this, the distance traveled by them is same, 1 by 2 a1 is same as a2 t naught square. Of course, t naught minus t has to be positive, time cannot be negative. So that is root a1 and plus, that's a relation. Okay, so t naught minus t, we got the relation. So from here we can find t naught also. So from here we can find t naught. So t naught is going to be into, I think we find t naught, and this is alright. And now what I can do is just this is 1, this is 2, you subtract from 2 and 1, this will be giving you what? a1 t naught minus t equals to v. Alright, and you have all the values now. You have all the values now. You can just put it, all the values. See, t naught minus t is also given to you. This is a1, and t naught minus t you can put it from here. And a2 t naught is v, and you have the t naught value. This is root a1 a2 minus a2, and you have the value of t from here, v. So from here what do you get? if I take root a2 outside, what I am left with is this. So this will cancel out. So I think you get this. Yeah, you get this idea. Okay. Okay. Let's move to next question. The question is, figure shows a rod of length L resting on the wall and the floor. Its lower end A is pulled towards left. You are pulling it towards left with a constant velocity V. Find the velocity of the other end downward when rod makes an angle of theta with the horizontal. Suppose this is X and this is Y and the rod length is L. So we have an equation, we have a constraint over here, that is x square plus y square is L square, and we have here V is dx by dt, right? And we are interested in finding dy by dt. Basically we want to find this velocity, right? So if I differentiate it, this will be 2x and 2y is 0, and dx by dt is what? V. So dy by dt is going to be xv by y, and x by y is what in terms of theta? Cot theta. So your this velocity in this direction is going to be, suppose this is v dash, so v dash is what? Minus dy. Why minus dy by dt? Because you know, as the time passes y is falling, so dy by dt is inherently a negative term, so minus I will make it positive, that is v cot theta. So the velocity in this direction is v cot theta. Alright, v cot. Dy by dt is inherently a negative term. Dy is negative, dt is always positive. So dy is negative, y is falling. As you pull the rod in left direction, this end of the rod will move in downward direction. So this is negative, and minus sign will make it whole thing positive. Alright, so this is v cot theta. Alright, let's move to next question. A man wants to reach point B on the opposite bank of the river, flowing at the speed as shown in figure. Let me draw the figure first. This is a figure. Okay, so a man wants to reach point B on the opposite bank of the river, flowing at a speed as shown in figure. Speed is u, basically it's given in the question. What minimum speed relative to the water should the man have so that he can reach point B, and in what direction he should swim? See, in order to reach point B, see, whenever a man is swimming, he'll have some velocity with respect to river, his own velocity, and he'll inherit velocity of the stream also. So net velocity of man will be velocity, his own velocity with respect to stream, plus velocity of the stream which he is going to inherit, and that net velocity should lie in this direction. That net velocity should be in this direction, and velocity of the stream is u, and this is the net velocity of the man, and that should be in this direction. Getting your point? Should I use this pen? See, what I was telling is net velocity should be in this direction. So suppose this is the velocity, net velocity should be in this direction, and you are given velocity of the stream, that is u. So his own velocity should be somewhere, say along this. We don't know exact direction, it can be on this side also, but that doesn't matter. I'll get the from mathematics. So suppose his own velocity is, say, call it v, and this would be v vector. So u vector. So v plus u vector. All right. Yes. And suppose this is theta. We don't know the value of theta. We don't know the value of theta. Theta, if theta is positive, it will be in this direction. If theta is negative, this is a reference. This is a reference for measuring theta. So if theta is negative, that means it will go in this direction. We will be in this direction. Theta is positive, that means it is going in this direction. Okay. And we want to reach point B. So net velocity will be along B. So this is A. Got the figure? This is his own velocity with respect to stream. This is the velocity of the river, and these two superimposed will give you net velocity, which must be towards B because he want to reach point B. Fine. So this is 45. So this must also be 45. If this is 45, then this is 45. So it should also be 45. Right? Now, if I apply law of sine law, it says this is A, B, C, this is alpha, beta, gamma. So the law says A upon sine alpha is B upon and C upon sine gamma. So in this triangle, so you see this is A, an opposite angle sine alpha, B opposite angle beta, B by sine beta, C opposite angle gamma, so C by sine gamma. This is something which you will study in trigonometry. So we can use this in this triangle. So this angle is 45 minus theta, and this is u. So I can say u upon the magnitude of u, the side length will be magnitude of u, sine theta minus 45 equals to, this angle is 45, so v upon, this u is given to us, v upon sine 45. So v is u upon, this is u, let's call it v. So u upon sine theta minus 45, and sine 45 will go on that side, so it will be 1 by root 2. So v min, what will be v min? V will be minimum if this value is 1. This value is 1. V is minimum if this value is 1. But this value will be 1 when theta minus 45 is 90 degree, and that will give you a very absurd value of theta, that is 90 plus 45, 135. 135 means the velocity has to be in this direction. There is no river in this direction. So that simply means what? That simply means that this v must be in this direction, and if v is in this direction, this is going to be a theta, and now this is going to be a triangle, and instead of theta minus 45, it will be theta plus 45. It will be theta plus 45, and in that case it would be a nice value. Then we'll get theta equals to 45 from here. See, if I take in this direction, theta minus 45 is 90, that will lead to an absurd scenario. So we must be on this side of the vertical, right? So it's theta plus 45, and it will be minimum when this is maximum, and maximum value of this is 1, that will be u by root 2, and direction will be in this direction. It will be in this direction with theta equals to 45. This is the direction of v. Alright, this is how we can do this question.